this. All right, so this is the exam number 2 from spring 2017. And as you can see that it was a joint exam made by both Dr. Sneed and me. And we have 3 problems, I believe. The first problem is short answer, 25%. It's a really simple one-way slab problem. You can see that this is quite similar to the lecture notes, and we just have a span, and we have this one-way slab, and trying to find out the BF, which is actually the transverse, effective transverse length. This is not actually one-way slab. I take that back. This is T-beam, right? So this is finding the effective flange width of the section, right? So beam A, meaning where's the beam A here? Oh, I think I label here. So beam A is right here. So trying to find the effective flange width for beam A, and beam B is right here, trying to find the edge of the flange width. Okay. Then 1B, circular corrective response, adding compression reinforcement for a given beam, significantly increased MN and increased the ductility. Yes, no, no. So it only increased the ductility, but not MN. Okay, so it should be C, does not significantly increase MN, but increase the ductility. All right. 1C, for one-way slab, reinforcement placed horizontal direction perpendicular to the slab plan span direction to the resisted stress due to what? Right, so look at this, reinforcement placed in the horizontal direction perpendicular to the slab span direction to resist what? It should be shrinkage and temperature, okay? All right, so 1D lists the 3 requirements given ACI 318 codes for using ACI moment shear coefficients. There are 6 requirements from the lecture notes, and you just have to pick 3, all right? Okay, 1E, this is 14, now it's 19. ACI 31819 states that maximum spacing for vertical stirrups, A, B, C, D, right? You have the equation, you can figure out, right? 1F, which is following, is now the mechanism, shear transfer, a reinforced concrete beam without shear reinforcement, blah, 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 blah. And we have talked about the transfer mechanism in the lectures, right? Easy pick. 1G, the ACI code requires user shear reinforcement and beam when blah, 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 right? So remember which one, right? So you know which one to select. 1H, general layout of the shear reinforcement, the beam shown below is most likely to be, this is the beam, and these are the relative spacing for the shear reinforcement, right? I just want to make a note here. Be careful. When you see this, draw the shear diagram first and find out where you have shear, where you don't have shear. Apparently, in the region where you don't have shear, you don't need to provide any shear reinforcement, all right? So for 1I, these are the critical sections we talked about, right? Try to draw the 45-degree line and find out the critical sections, all right? We have talked about this in the lecture notes, and in the exam, we're gonna have a different figures, but similar idea, you got it, okay? Now, this is calculation. Now, problem number 2, I made it more like a multiple choice calculation, okay? So here you see a one-way slab. And notice that the end of it is a column, not not an L shape of integral. So you might have to pay extra attention when you use the moment coefficient, which row of coefficient you have to use based on the lecture notes. Okay. All right. Estimate appropriate slab thickness using the ACI 318 code. We have talked about this in the lectures, and you can find the equation for it. All right. To B, determine the coefficient. Apparently A, B, C, D right here. Which coefficient to use, just take a look at the lecture notes, right? There's a table knowing which row to follow, and you can find the corresponding coefficients. All right. To C, using the coefficient, find out the bending moment, MUB, MUD. This is entirely covered in the lecture notes. Okay. To D, design flexion reinforcement, the middle span location B, perform necessary code checks. This is designed for longitudinal reinforcement at mid-span location B using the one-way slab design lecture notes, which said before, right? And then the last one, shrinkage temperature, you know how to do that, right? So that is problem number 2. Problem number 3, we get lucky and we ask you to just calculate irregular sections. We have a huge opening, right? And you find the moment Mn and you find the Phi I just want you to notice that if we were asking you to use this section for shear, the BW will be this narrow width plus this narrow width. Okay, but this is not for shear, so you shouldn't have that problem. and you can follow our lecture notes and homework to solve this problem. All right. Okay, this is additional problem. Now, in our exam, it's probably going to be only three big problem, not four. Okay, what I will do is I combine problem one and two into one big problem number one. Okay, so for problem number four, in this case, this is basically shear. So have a PU here, concentrated force. This is more like a simply supported, but no, we have actually fixed. But it doesn't matter. You can find the shear diagram. We have illustrated one example through the lecture notes. You have to find a shear diagram, find the critical sections, and determine the stirrup spacings with different regions. All right, so this is not much different from the lecture notes. Like I said, the only thing that is a little bit tricky is that the section has an opening in the middle, 5.5 inch, and then you have this narrow width on the side. Okay, so when you find a BW, that should be 15 minus 5.5. That is your BW, the width of the web, when you calculate the cross section for concrete. Okay. All right, and I think that's all. Okay, I have one question from chat. I'm going to answer that. Are you going to share this old exam? No, I'm not going to share this exam on Canvas, Luis. I'll post this video, meaning that most of us will see it already. And now I think this is all. And I will end the recording and I will spend some time with whoever participated office hour as a bonus. Okay, so let me stop sharing right now and let me stop recording and I will start answer your questions. Okay. All right. For most of us, I will quickly go through this on Wednesday, which is tomorrow morning again. Okay. All right.